Here we go. We have a question. Count total number of colored cells. So there exists an infinity large two-dimensional grid of uncolored unit cells. You are given positive integer n, indicating that you must do the following operations for n minutes. At the first time, color any arbitrary unit cell blue, then every other minute afterwards, we need to color blue every uncolored cell that touches a blue cell. So it's kind of a flood fill. Below is an pictorial representation. So here we have n as 3, so this is the time 1, so the time 1, and at time 2 it will spread, the blue color will spread on 4 directions. Then so this blue box represent the second time. Then on the third time it will further spread on the 4 direction, and that's all about for these 3. Then we need to return the total number of colored cells after n minutes. So on minute 1 we only have 1. So on time 1 only 1 cell is filled. Then on time 2 we have 5 cells, and n can be very large, so we need to find the total number of colored cells. Let's build the approach. So we have on time 1 we only have one cell. Then it will spread into 4 directions. Then it will further spread this onto these cells. So how many of these further cells? So we have 1 2 3 4 5 6 7 8. Here we have 8 cell, and here we have 4 new cell. And on time 4 how many new cells we will be having? So 1 2 3 4 5 6 7 8 9 10 11 12. So on time 4 we have 12 cells. So can we write it like this: 4 cross 1, 4 cross 2, 4 cross 3, and here 4 cross 0, right? And on time 1 we only have one cell. Then this will add up on our previous answer. Then this will add up on our previous answer. Then this will add up on our previous answer. And on time 4 we have that many new cells, and previous will also included. So we have that many new cells. So we start with number of cells. So let's say our answer is initially 1. Then for every other minute, so we can start from either from 2. Yes, we can start from 2. Then we will go till n. Then on every single minute we have 4 cross I, right? But here I think 4 cross we have to start from 1. Yes, we have to start from 1, and it will go till less than n, right? So we have 4 cross I new cell. So in our second minute we have 4 cross 1, means we have 4 new cells, and this will add up onto our answer. So answer is equal to answer plus that many new cells, and at the end just return the answer. So let's build the approach. Let's code this. Code is going to be very simple. We have initially answer as 1, then it will start from 1 till n, and answer is equal to answer plus 4 multiply I. Just return the answer, and I hope it will work. Yes, let's submit this. Yes, submitted, fine. And in this the time complexity is order of n. So let's come here. So in this the time complexity is order of n, and space is constant. But there's an approach 2 which is very interesting, and here we can reduce the time complexity to order of 1. So this is a mathematical calculation that we can do. So here we have 4 cross 1, 4 cross 2, 4 cross 3, right? So 4 cross 0, and on our second iteration we have 4 cross 1, then 4 cross 2, then we have 4 cross 3. So we can take 4. So initially we have 1 here, and 1 plus we can write 4, 1 plus 2 plus 3 up to n, right? So for 3 we have n minus 1 till n minus 1, right? So we can write it like this. So what is the total calculation of this? So n multiply n minus 1 by 2 and 4. So we can write for like this, n minus 1, so it is 2n n minus 1 plus 1. So let's code this. I hope it will work. So first let's directly return the answer. 1 plus 2 multiply n minus 1, and let's denote it as a long, and let's submit this. And yes, working fine, beat 100%. And this is the fastest approach. In this, the time complexity is constant, space is also constant. Thank you all for watching.